Good afternoon. We're going to discuss today regarding classless addressing scheme. Classless addressing scheme in which the classes are not defined, like what we have discussed in the last video, where we were talking regarding the dividing these given IP addresses into a different classes. We concentrated on class A, B, C, and the other two addresses, they are meant for some special purposes. So excluding these are the three classes of addresses where the network address, actually the address which is of 32-bit, got divided into two parts. In all these addressing schemes, we are dividing this given 32-bit address into two blocks. The first block, okay, so that is leftmost block, it going to represent the network address, and the rightmost block, that is this part, will going to represent the host address. Now these classes are mainly defined based on the size of this block. Okay, size of network block. So in class A, the network block size is large, class B smaller than A, class C is very smaller than that. Okay, so in class A, okay, actually there is some correction. Class A block is smaller, class B block is larger than A, class C block is this network part is bigger than B. Okay, so like this it goes this way. So when you look at the class A block, so you're going to have a smaller block here, you're going to have more number of hosts can be addressable. This is for class A. When it comes to class B, so where this particular block will be larger than this, and when it comes to class C, the network address block is very large compared to that of B. So in terms of bits, if I address this issue in terms of bits, okay, so number of blocks in class A, that network part address, okay, number of bits of network address is 8-bit in class A, and in class B it is 16 bits, which is meant for addressing the network part, and class C you are going to have 24 bits meant for identifying the network. So out of these 8 bits, actually 7 bits are variable, 1 bit is fixed, MSB bit is fixed. When it comes to class B, 2 bits are fixed and remaining 14 bits are variable. Okay, altogether it is 2 plus 14, it is 1 plus 8, 1 plus 7, and this one is 3 plus 21. Okay, so like this we divided the classes. Now we'll talk of a scheme which try to overcomes the drawbacks of this classful addressing scheme. So the major drawback I discussed in the last video. So to overcome that particular problem and utilize these IP addresses in a better way, we talk about classless addressing scheme. So in classless addressing scheme, the idea that was used in a classful scheme is retained as it is. So we are not actually dividing them into a classes, but the idea that was used, that MSB part was meant for addressing network, LSB part was meant for addressing hosts, that idea was retained as it is. And then based on the requirement, this length they vary. Okay, actually here they have a more flexibility compared to that of classful scheme. In classful scheme, you are restricted only to a specific classes, okay, whereas you have a flexibility over here. So in this case, basically, when it comes to a classless scheme, we talk of, say, the network block. Say most of the times we're going to call it as, say, block addresses. So this is of variable length block. Okay, So this is of variable length block, and say the address space is divided into a variable length blocks, and this actually what it means is variable length block means you are not talking about here in classless scheme. The block means this part. Block means this part. We are talking of creating addresses of variable length blocks. I'm going to have say block of different sizes which will be used for addressing the networks. Now this variability they maintain mainly because to get a flexibility of allocating the host addresses based on the need of the customer. So in classful scheme, what was happening when a customer asked for the 500 IP addresses, what was the option there? That was the only option was go for class B. If you go for a class B addressing scheme, how many addresses you will going to allocate to your customer? He is asking for 500, whereas this scheme forces you to apply say allocate him 2 raised to 16 different IP addresses. So what was the thing? He was asking for 500, whereas you have allocated him 2 raised to 16. Now he could use only 500 out of it. 65,000 IP addresses you will go to waste here. Roughly 65,000 IP addresses will be wasted in classful scheme. Now just to overcome this particular problem, we are talking of allocating these IP addresses based on the requirement. So that is why we are providing the flexibility of varying this block size, this IP size. So this network address will going to be allowed to vary. Rest all the things will going to be remained as it is. Plus based on his requirement, this part, this block part is going to be varied. Okay. So normally if a user asks for a 500 IP address, okay, the next the IP addresses will not going to be exactly allocated him over here is not 500. It will be in terms of the next number which is greater than 500, which is again a power of 2. That many number will going to be allocated to him. Say for example, if he is asking for say 500 IP addresses, he is going to be allocated 512 IP addresses, because here the allocation will be done by using power of 2. Okay, so that idea has been used over here. So because of which you will going to have a less wastage of IP addresses, which was say more in case of say in classful addressing. And this idea of classless scheme has come into the picture once ISPs started coming into an internet world. So basically these are the network service providers. So moment they entered into this field, this classless scheme has come into the picture, and which helps these ISPs to provide the needs of say smaller customers, such as a single user customer, say the single user customer of ISP, say some small block of say small organization will be the, if he is a customer of this ISP, and if a medium-sized organization is a customer of this ISP. In such situations, this classless scheme will be very useful in allocating the IP addresses. So this kind of a scheme is not again a burden on say smaller users, and again it will be also helping us to overcome the problem of loss of IP addresses. Okay, so this is the reason why this classless scheme has come into the picture. So in classless scheme, when it comes to say specifying the IP addresses, as it was known to you, there will be two parts in the IP address. One is prefix and this is suffix. We call it as suffix. So normally to identify the block size, here we are talking of adding a slash in front of IP address. So here too in classless scheme, we represent these IP addresses in a dotted decimal notation. So what exactly this dotted decimal notation is? So given 32-bit IP, so the 32-bit number, which is a binary number, 32-bit, which will going to be divided into a blocks of 8 bits. So how many such blocks will going to be there? There are 4 such blocks. 4 8-bit blocks will going to be there in this 32-bit. So you are dividing this given 32-bit into a 4 8-bit blocks, and every block will now going to be represented by a decimal number. The highest decimal number what we can use over here is 255. Lowest is 0, and any number which is between 0 and 255 will be the part of this IP address. So, and each 8-bit values which are represented in a decimal are separated by a dot. So that is the reason we call it as dotted decimal notation. I hope it is clear to you. So this way of writing a IP address is also used in classful scheme, and the same is also retained in the classless scheme. So the representation of IP address is not changed, but to understand or to know how many bits are representing a network part and how many bits are representing the host part, what we need is some kind of arrangement in this representation. See, if I provide an IP address of some machine in this way, it is difficult for the router to know, say, how many bits are there in it which are used for identifying the network. So for that reason, what we do is in classless scheme, we use a slash notation to say represent the network part address or prefix address. So if I say slash 24 here, the first MSB 24 bits are a prefix address. Prefix address here indicates a network address. Okay, so first 24 bits are prefix address or network address, and remaining 8 bits are meant for identifying the hosts. So that means out of 32 bits, the number what we are specifying here is useful in identifying the network part address. So these type of schemes, this type of representation will be useful for the routers. Why we need this type of representation? Mainly, see, network, when the packets are getting routed to the different destinations, okay, whenever they arrive at a router will make a decision based on the IP addresses that is present in its header. But normally, if you present complete IP address to the router, it takes a lot of time, or it needs a router to maintain a bigger or a larger routing tables to route the packets. Okay, to avoid all such things, what happens, rather than keeping a complete information about all the hosts that are belongs to some particular network, it is easy to maintain only the network address in the routing table, and it will be also helpful for the router to route the information faster rate, because once the table sizes are smaller, okay, finding the value in the routing tables will be very fast, and this helps the routing action to happen at a faster rate. So for that reason, what they do is, rather than perform a routing using complete IP address, what they do, they simply use the network part of the IP address for routing purpose. Okay, they use only network part of the IP address to route the packet to a different destinations. Now, why this idea? Once a packet reaches some specific network, the router which is present at the gateway of that specific network will use the host part address to route the packet to a specific host. So this idea they use over here. You are not putting complete burden on one router to make route the packet to a specific destination. You are reducing the burden of this router so that it can only reach this network part. Rather than going to a final destination, say what it will do is, it will try to make the packet to reach the specific network to which the host belongs. Thereafter, it's a gateway router's job to forward it to a specific destination. So basically this idea is used to speed up the routing action. Okay, so this type of idea is also used in, say, classful schemes. Now in classless, as I said, it is necessary for the routers to know what is the part of prefix or how much bits are there in the prefix. For that reason, we specify the number of bits that are part of the prefix with the help of this notation, slash notation. Using the slash notation, here you are going to have that dotted decimal number. Yes, then slash, the value which you are specifying here is indicator of the number of bits in the network. Okay, so number of bits are there in the prefix part, or otherwise you can say number of bits that are there in the block part. So block in a classless scheme is nothing but network address. I hope it is clear. So this is all about classless addressing scheme. So when it comes to a classless addressing scheme, basically it is important to know what is the starting address, what is the end address, and the number of addresses in the block. So all these things are required to know over here. So for that, the scheme that is used to know the number of addresses in the blocks is, say, the number of addresses in the block is found is equal to 2 raised to 32 minus n. So where a capital N represents a number of addresses, say, that are present in the block, where a small n, okay, small n represent the number of bits that are present in the prefix. Number of, say, the small n is number of bits that are there in the prefix. Say for example, if I talk regarding my IP address, prefix is of 24 bits, and how many bits will go to be here? It is 8. So 32 minus 24 will going to give you the value 2 raised to 8. 2 raised to 8 is nothing but 256. So number of block of addresses 256. So number of address in the block is 256. Okay. So how many number of hosts you can address, that you can come to know by this n value. So if it is 24/24, then it is 256. If it is 23, in that case it becomes 2 raised to 9. So number of addresses in the block is 512. So that means it is possible to address 512 using this type of addressing, where 23 bits are reserved for network part and remaining bits, 9 bits, which are reserved for host. With the help of this type of a division, we can address 512 hosts. Okay, basically when it comes to allocation of IP addresses, so these ISPs also will going to get certain range of IP addresses. Those allocations to the ISPs will going to be done by international say organization ICANN. Yes, this will going to allocate the IP addresses to a hosts. Okay, so I think it's ICANN. Okay, so this will going to allocate the addresses to ISPs, that is International Corporation for Assigned Names and Numbers. Okay. Now the next thing is to find a first address of the block, first address of this classless scheme. Okay. To find the first address, we keep leftmost n bits, say, as it is, that is without changing it. That means if I have n bits in my prefix, say for example 122.15.16.0/23. If I say like this, okay. So first 23 bits, MSB 23 bits of this address, MSB 23 bits of this address will going to be remain as it is. It will be remain unchanged. It will be kept as it is. Whatever the thing that is specified, that will be retained as it is. And last bits, these bits, that is 32 minus n. In this case, n is 23. So how many bits will going to be left out? It is 9. Yes, these 9 bits will going to be made 0. Yes, all those 9 bits will be made 0. The first 23 bits will be retained as it is. So this gives you the first IP address of that block. First address of that block. What will be the last address of the block? Same idea. So you set all these bits to 1. All 9 bits will go to be set to 1. So first, this gives you the last address of that block. The first address you are obtaining is by setting all of them to a 0, all these 9 bits, and setting all these 9 bits to a 1. So you will go to get the last address. This gives you a first address, this gives you the last address. So this part will go to remain same in these two cases. The 23 bits in this example, 23 bits, MSB 23 bits remains as it is, LSB bits are changing. So that gives you the first and the last address of that block. So this is how you need to find the first and the last address of the block. So this is regarding classless addressing scheme. Okay, we'll try to discuss one example. One more thing regarding, say, finding the addresses. So that is one way of finding the address is using the address masks. Address mask here is basically, this too is helpful in finding the first address or the block address length. It will be useful, address mask. So when the address mask is nothing but, so I'll take example from that, it is easy to know. Yes, if I say 24, so this indicates first 24 bits are meant for identifying the network part. To know the starting address of this particular block, you are using address masking technique, where you are performing these 24 bits. First 24 bits you are making them all ones, and remaining 8 bits you are making them to a 0. So if by taking this number you are adding to a given number, given IP value. So from that it is easy to find out what is the block size, what is the first address of the block. Okay, so if you add this with this, you will come to know what is the first address of the block. This is where, say, the address masking technique means you are masking, say, the address bits. From that you will come to know what is the starting address.